Student Professor Dr. Dolphy Gilpin. As I promised, let's do some exercise in Newtonian calculus. Some differential, simple differential maths. And we'll just use the law of differentiation to differentiate. Let's put suppose now x y equals now x to the 20 per se. You could go high or low. Let's start it plus x to the 10 plus x squared. We're not going to try to make it difficult here. And we say now that D1Y by dx will be equal to x to the 19th plus 10x to the 9 plus 2x. Now, d squared y by dx squared will be equal to, just differentiate this term one more time, 20 times 19 times x to the 18 plus now 9 times 10 x to the 8 plus 2. We would call this also y prime. And this one as y double prime. We say now that d cube y by dx squared, d cube x, or dx cube rather, would be just differentiating this term one more time. So we get now 18 times 19 times 20, x to the 17th, plus now 8 times 9 times 10, x to the 7th, and this would be 0. This would mean 2x to the 0. And this, we call it now y triple prime. Now, if A equals okay, we'll not complicate things as yet. Let's just continue on the simplicity mode here. Okay, so we have d4y by dx4 now will be equal, and this would be a simple additional math at ordinary level. Yeah, encountering differentiation, even though the index and the indices are high, this would be what we call additional maths. at ordinary level or intermediate level. Let's go. So we have now 18 D4XY by DX4 to be equal now 17 times 18 times 19 times 20 x to the 16 plus now 7 times 8 times 9 times 10 x to the 6. And we call this now y IV. Coming down now, we say D5Y by DX to the 5th will be equal now to 16 times 17 times 18 times 19 times 20 multiplied by x to the 15. Let's use the dot here again. Dot x to the 15. Plus now 6 times 7 times 8 times 9 times 10 x to the 5th. And that will be equal to y, where yv is equal to the 5th differential order. Coming down, we'll have d6y by dx6 will be equal now to 15. This is simple conventional Newtonian differential calculus here. We're differentiating. We have Newtonian integral calculus. 17 times 18 times 19 times 20 x to the 14 plus 5 times 6 times 7 times 8 times 9 times 10 x to the 4th. And we call that now y v1r. So now d7y by dx7 will be equal now to 14 times 15 something is left out here. We're 16. X 16. So 16 times 17 times 18 times 20 x to the 15. So 15 times 16. 15 times 16. 14 times 15 times 16 times 17 times 18 times 19 times 20 x to the 13th plus 4 times 5 times 6 times 7 times 8 times 9 times 10 x cubed, we call that y. And d8x by dx8 will be equal now to 13 times 14 times 15 times 16 times 17 times 18 times 19 times 20 x to the 12 plus now 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 x squared. And we have now d9x by dx to the 9 will be equal now 12 times 13 times 14. X to the 11 plus now 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 x, which means x to the 1. So the next time we differentiate, this term will drop out and become 0. So we have now D10x by DX to the 10 will be equal now to 11 times 12 times 13 times 14 times 15 times 16 times 17 times 18 times 19 times 20 x to the 10 plus 0. And so now D11x by DX11 will be equal now to 10 times 11 times 12 times 13 times 14 times 15 times 16 times 17 times 18 times 19 times 20 x to the 9th. And this other term is 0. And let's go to 12. D12x by DX12 is equal now to 9 times 10 times 11 times 12 times 13 times 14, 15, 16, 17 times 18, 19 times 20 x to the 8. And we will sort of leave it at that. And this is now X to Y. So I've reached down now to the 12th differential order, and our papers run out, and we'll also take a break at this moment and do that. We'll move on from here to differential equation itself, boundary value problems. When you actually set these differential equation and boundary value problems, when you put in values for x and y. We'll take a laugh here. A ball being hit to the boundary for 4 runs. The boundary is way out there in the field, and when the ball crosses over that boundary, it's 4 runs. Or when it goes and drops over the boundary, that's 6 runs. Boundary value problem.